Okay, so today we're going to fine tune this. At the end of today, you're going to know how to do piecewise graphs, okay? So it is 2, 4, 22. Our objective is to graph piecewise functions and create the equations of piecewise functions. So we want to do two things. We're going to graph them, and then like on example 2, we're going to find the equation, okay? We can do both. We're going to graph them, and then we're going to create the equations, okay? All right, so what's the first thing we do? What's the first thing we should do to do number 1? The boundaries, right? There's my boundaries. So let's find my boundaries. So x-axis, right? -5, 1, 2, 3, 4, 5. There's -5. -2 on my x-axis. 1, 2. +2 on my x-axis, 1, 2, and then +5, 2, 3, 4, 5. These numbers are invisible, but I like to have them in there because they really help me see my regions, right? So I have 3 regions. Great, I've got 3 graphs. My first line is y equals 2. F of x, y, same thing, except for it's a function. I know that's a horizontal line at 2. So 1, 2, and I draw my horizontal line. Of course, I use pencil because I'm not going to keep all of this line. I'm only going to keep the part of this line between -5 and -2, so I erase all the rest. Okay. So if you're absent, this might really be a good day for you, huh? So I put my y equals 2 line only between -5 and 2. Now, I'm also going to put a solid dot at -5 and a solid dot at -2 because it equals -5 and it equals -2. Line 2 is a y equals -1/2 x plus 1. So that's a y-intercept at +1. A slope of -1/2, which is down 1/2, down 1/2. So my line looks like this. My graphs are overlapping. You can't have that. They can't overlap. It wouldn't be a function, so I have to erase some. So this line 2 is in between -2 and 2. So I'm going to erase the rest of this. They are connecting. They don't have to, but I like it when they do, so I try to create ones that do, okay? At -2, it's already a closed circle, which that's good because I don't want to close it again. Yes?
It says -1/2 x plus 1.
Yes.
I'm not sure where the +1 is, so to speak.
Yes, that's my y-intercept. And so, Ava, what I did is on the y-axis, I started at +1. Does that help answer that question?
Yeah.
Good. And then I just did my slope of down 1/2. Please always ask questions, you guys. Thank you. Okay, line 2. And oh, I've got one more thing. Right here at 2, I'm going to make a closed circle, right? Close circle there. This was open, but it was already closed from the graph before. Line 3 is y equals x minus 2, but I'm going to put in some invisible numbers, 1 over 1x, because it just helps me graph to put in the invisible numbers. So Ava, same thing on this one. We'll start at -2 on the y-axis, right? That's my y-intercept. I'll start down here. So be careful. This is where kids make their first mistake on this, but you're not going to. You're not going to make this mistake. This -2 is a y-intercept. Don't put it on this line, correct? That's just an invisible line. That's an invisible line. So it has to be here. Not there, but there, okay? And then I'm going to go ahead and apply my slope, which is up 1 over 1, up 1 over 1. So my line looks like this. But there's a whole lot of overlapping. I can't have the overlapping, right? Only going to draw line 3 between 2 and 5 only. So erase this. And so I'm also going to make sure that my line doesn't go beyond 5. Because my boundary is from 2 to 5, okay? Thumbs up. Or sideways. I don't mind sideways. If it's down, down's okay too. Okay, where are you at? Let me see. I want to see everybody, okay? I want to see everybody. Thumbs up. I see a bunch of thumbs up. Sideways is fine. Okay. Okay, good. Now, let's talk about domain real quickly. Domain is how wide, okay? Let's talk about domain. So this graph goes from -5 to 5, doesn't it? So, if you don't know how to write set notation, you can write, and I'll take it because it's understanding on domain. If you want to write from -5 to 5, great, I'll take it. I would prefer this. And the domain is really right here. It's in your question. Do you see your domain is x's? Really is from -5 to 5, okay? Your range. Reach for your range. And again, if you were to tell me on range, and I'll take it on a test, from height of 0, right? Height of 0 to height of 3, if you say from 0 to 3, I would take that. I would prefer, you tired guy or just ready to go, I would prefer this. I would prefer 0 is less than or equal to y, which is less than or equal to 3, okay? Domain and range. How am I doing? All right, example 2. Let's do the opposite. Let's make an equation, okay? So first of all, I have 3 lines. So I like to do this. Line 1, line 2, line 3. I just like to write what they are. And let's take a look at line 1. Line 1, so I'm going to put up here y equals mx plus b. I'm going to use that equation, right? Because anytime it's a slanted line is going to have a slope, right? Slant line is going to have a slope, and it will have a y-intercept. So, but here's the deal. The y-intercepts have been erased, but we still need it, okay? The y-intercept has been erased, but we still need it for the equation, okay? So let's take a look at the first line. So line 1 is slanted, so I'm going to use my y equals mx plus b, but the slope is down 1 over 1, down 1 over 1, down 1 over. So I'm going to go -1 over 1x plus, well, actually not even plus, but minus, and it got erased. It got erased if I just draw it all the way in. It was -1. It really was -1. That's important because if you don't put that, then it puts the line in a different place. So -1. Okay, line 2 is straight across horizontal, right? So it's a 0x. Line 2 is just plain old y equals 3. line 3 is a slanted line, so it's going to have a slope. Up 2 over 1, up 2 over 1. So we're going to go y equals up 2 over 1x. And it had a y-intercept. And I'm not sure where the y-intercept is. Okay, Camille. But we got to figure this out. Okay, the y-intercept, let's see. Now I can try and draw my graph down further. Now this is going to take some thinking, and I'll go through it slowly with you, okay? We're at height of -3, right? So if I go down 2 over 1, I'm at a height of -5. Does that make sense? If I go down 2 over 1, I'm at a height of -7. Just logic, right? If I go down 2 over 1, I'm at a height of -9. Okay? Thumbs up? Makes sense? Down 2 over 1, okay? So let's put that on there, okay? So it crosses at -9. Even though it got erased, it crossed at -9. Okay, so -9. Now, we have borderlines, right? Here, 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 and here. Line 1 is in between -4 and -1. Line 1 is in between -4 and -1, so I write this. If we're between -4 is less than, x less than or equal to -1. All right? Smart kids. All right, smart kids. There's no equal sign here, right? Because there's an open circle. All right, good. Then, for line 2, we're going to say it's between -1 and 3. So say if -1 is less than x, which is less than or equal to 3. Right? And no equal sign because it's open. Equal sign because it's closed. And then finally, line 3 is between 3 and 6. So we'll say if it's between 3 and 6. Open circle at 3, no equal, closed circle at 6. Now, let's put it all together because I really want it to look like, I want it to look like this, okay? I want it to look like this. So let's rewrite it. So I'm going to go, okay, f of x is equal to, put my squiggly down, my brace is what it's called. I'm going to go a -x minus 1 if -4 is less than x, which is less than or equal to -1. Y equals 3, or fx equals 3 if we're between -1. -1 is less than x or less than or 3. And y equals a 2x minus 9 if 3 is less than x, which is less than or equal to 6. Okay, turn the page whenever you're ready. All right. Now, let's graph this. It's an absolute value, right? So an absolute value graph is a V, right? So let's find the vertex first. All right. Just a little dance. Just a little dance. Okay. It wakes me up, huh? Why am I doing this little dance? Just to make a fool of myself? Yes, but why else? Because I'm not going to go back 4. I'm not going to go left 4. I'm going to go to the right 4. Because it's inside the parentheses. It's a horizontal movement. So we're going to go and put our vertex at positive 4, negative 6. Okay, so I'm going to do that. Let me get my red pen out. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6. Okay? I have a slope of 2. So I'm just going to go from my vertex up 2 over 1, up 2 over 1, up 2 over 1, 2 over 1. I'm going to graph it in. Okay. All right, the teaching moment when you're ready. Teaching moment. The silly, stupid little dance. And it keeps me awake, doesn't it? Right? It's Friday morning, right? But here's why it works. The vertex is the very lowest value, correct? It's the lowest, very lowest y value. If x were 4, right? If x were 4, what's 4 minus 4? 0, which puts it at the lowest spot. That is why. Now, if you still didn't understand that, that's okay. I promise I'm going to talk about that again. Because it can't be just like, oh, Mr. Davis says a silly little thing here, on the inside, the opposite. There's a reason that it is the opposite. What value? It's always the opposite value that would zero it out, wouldn't it? It's always the opposite value that zeroed out. Okay, now, awesome. Now, if we wanted to make this into a piecewise function, we can count this as two different equations. Equation 1 and equation 2, right? Equation 1 is going to be and again, I'm going to use y equals mx plus b because they're slanted. They have a slope. Equation 1 is going to be y equals down 2 over 1 x plus, let's see, 2, 1, 2, oh, it actually goes right through here, plus 2. Okay? Are my freshmen leaving? Okay. I mean 8th grader, sorry, my bad. So if you're an 8th grader and you're heading out, it's right here, okay? An 8th grader heading out here, okay? So, equation 2 is going to be a y equals a positive 2 over 1x plus or minus what? All right. Let's see if we can get this y value. Let's do it. Let's walk it down. Okay? For the height of. Right? Okay? So we're going down to negative 8. Going down to negative 10, right? Going down to negative 12. Going down to negative 14. See, I got that? Even though it got erased, it would have crossed at negative 14. Did you get that? So let's put that in. Bye, guys. I'll see you Monday, okay? Okay, so minus 14. So, where's my borderline? My borderline is at 1, 2, 3, 4. Well, it has to be 4, right? We know that. There's my borderline. This borderline's at x equals 4. Graph 1 is x is less than 4. Line 2 is x is equal to 4. TJ, you get to pick. So this point right here has to count. Doesn't matter to me. Do you want to give it to line 1 or do you want to give it to line 2? Doesn't matter. Line 1. So equal there. Can't put it on both. You guys agree? But you have to put it in because we need to count every point. Oh, thanks, TJ. So it doesn't matter, does it? It does not matter as long as we count that point. TJ says line 1. Okay, so we're ready. F of x and y are the same thing, right? So y equals, or fx equals a negative 2x plus 2 if x is less than or equal to 4. Yes, Tava.
Can it still be a function if there's a gap in the middle?
Where's your gap in the middle?
There's not actually one on this one, but like, say that neither of them had that point.
Yes, it would still be a function. Yes, it would be a discontinuous function. Ooh, because I'd have a hole and I'd have to start again. How do you like that word, discontinuous, huh? So it'd be a discontinuous function, Tava, because we'd have to stop and start again, but it would still be a function because it still passes that vertical line test, doesn't it?
Yeah.
Good question. Okay, so then 2x minus 14 if x is greater than 4. Awesome. So you're saying if I didn't have an equal on either one and had a hole there, yeah, it would definitely be a function. Okay, so I have homework today, and it's a worksheet. And, you know, try and work on it. I'm here to help.